In this Mission 3 Chapter 6 video, we will learn what is multiplexing. So this is a typical communication link which consists of transmitter, receiver, and a channel as a medium for transmission. So through this channel, the signal from the transmitter side will be sent to the receiver side. And the communication link in the channel can be wire or wireless. When there is multiple transmitter and receiver, the communication link can be shared by a single channel, and this process involves multiplexing. So, multiplexing is a process that allows simultaneous transmission of multiple signals through a single channel. Now we know what exactly is multiplexing. In this video, we will go through three types of multiplexing. First is frequency division multiplexing, in short FDM. Second is time division multiplexing, TDM. And third one is wavelength division multiplexing, WDM. Now let's talk about frequency division multiplexing. So this is a complete structure or component for FDM. On the left, we can see there's a three different pattern of signal need to be transmitted. Before it goes into channel, we have multiplexer to combine all the three signal. After the multiplexer combine all the signal pattern is now become a series of time and send it to the channel. On the right, a demux is used to separate the signal and obtain back the original signal. A demux is usually built with a band-pass filter and a low-pass filter. Now we will talk about the application of FDM. The FDM is quite common and is usually around us in our daily life. First is AM, FM radio broadcasting. Second application is television broadcasting. Third is telephony system. Now we will go into second type of multiplexing method, which is wavelength division multiplexing. In short, WDM. WDM is actually having the same concept as FDM, but with light wavelengths instead of radio frequencies. It allows for a higher data transition rate because optical fibers have a much larger bandwidth capacity compared to radio frequency. WDM also provides inherent security and isolations between signals. Since each signal is transmitted using a different wavelength, they do not interfere with each other. This ensures that the signal remains separate and can be easily demultiplexed at the receiver end. Next, we will talk about time division multiplexing, TDM. TDM is a digital technique that allows multiple signals to share a common channel by dividing them into fixed length time slot. For example, here we have three frames, frame 1, frame 2, and frame 3. Just before multiplexer, and each frame consists of 3 time slots which can insert the signal or data for the transmission. The signal will be divided and sent it frame by frame using a multiplexer. In frame 1, we're having A1 and C1 data. In frame 2, we're having A2 and B2. In frame 3, we're having all the 3 data, A3, B3 and C3. All the data will be sent slot by slot and frame to frame to the receiver end. And that's all for this video.
Thank you for your attention and good luck for the quiz.
Hello, good morning. So today we are going to learn about pulse modulation for communication principle, and my name is Lo Xiang Hong. Okay? So what is pulse modulation? Pulse modulation is basically how we turn digital signal like 100 Hz, 1000 MHz into ones and zeros. That's all that is about pulse modulation. And then we have type of pulse modulation, like type of methods that we use to convert from analog signal to digital signal. So there are 5: PCM, DCM, ADPCM, and then DM, and then DAM. But today we are only going to learn about the first one, pulse code modulation. So what are the advantages and disadvantages about using a digitalized form of signal? So number one is immune to noise. In communication, noise is like disruption, okay? And then the second one is easy to store and process because it is in digital form. And in digital form, it is only ones and zeros with generation, and then easy to measure because in digital form there is only one and zeros. Enable encryption, that means the signal will be protected. And then we have data from several sources can be multiplexed and transmitted using the same digital communication system, which means if there's multiple signal, it can be transmitted using the same line. And we have error correction detection can be utilized. The disadvantages of using digital form is that it requires a lot of storage, so bigger bandwidth. And the obvious one it need to be converted to the digital first, and it is not compatible with analog system. And the lastly is need synchronization. Okay, so next is how to take proper sample from analog signal. So there's a rule, or we call it a theorem, that we need to follow for taking a sample from the analog signal, and then we can use that sample. So the sample is So the theorem is called sampling theorem or the discrete theorem. This theorem states that the sample rate of an audio signal needs to be at least twice the maximum bandwidth. If not, we will get the totally different signal from the analog. So there are three types of sampling method. The first one is the ideal sampling, the second one is the natural sampling, and the third one is flat top sampling. Flat top sampling is not recommended because, as you can see, it doesn't follow the sine wave. There's a bit of error here, and therefore the ideal sampling is quite difficult to get this line, so we most commonly use natural sampling. So pulse modulation index, let's go more detail on this one. So there are four common terms that we use in PCM, and the first one is quantization level, quantization interval, quantization value, and the last one is quantization error. So let's see what are these four. So for quantization level is how many level there is. So from 0 to 7. How do we know there are 7 levels? Here is the formula. L means level and N means net bit. Okay, so for quantization level, we have 8. How do we get 8? So let's say N. N is the bit. That is the system of bits. Let's say you use 4 bits. So 4 times 2 is 8 bits. 8 bits means there is 8 levels. 8 level doesn't mean from 1 to 8. It's actually 0 to 8. It includes 8 in the calculation. So next is quantization interval. Quantization interval means the difference between each of the levels voltages. So how do we know the first one? We have to use the peak to peak, that means plus 5 volts minus negative 5 volt, we get 10. So 10 divided by 8, we get 1.2 volt. So the difference between each level is 1.2 volt. Okay, next is the quantization value. Quantization value is just the voltages for each of the levels. And then quantization error. Quantization error is actually the difference between the actual signal and the signal that we calculated. So we want to minimize this as much as possible. Okay, that's it for this talk. I hope you can answer the questionnaire later on. Thank you very much.